Okay, picking up, so we have these three facts, just of highlighting a few more, the importance of things. So like this first one said, if it's on a closed interval, continuous on a closed interval, you have both an absolute max and absolute min. So if we look at this first picture here, on an open interval, negative infinity to infinity, we see there's an absolute minimum here of 2, but there is no absolute maximum. That part about being a closed interval is important. And I was lazy on my graphing and I didn't bother to make the computer put arrows there. But that part of being about an open interval is important, or about being on a closed interval is important for the guarantee of an absolute max or min. And on the next one, again on an open interval, there is no absolute extremes. So not every function has to have absolute extremes. The only thing that you are guaranteed about absolute extremes is continuous on a closed interval. Okay, we're going to spend a lot of time finding critical numbers. Now when you get to the homework over this, there is no one problem, I don't think, or there aren't a whole lot of them that say just find the critical numbers. We are building two very long problems in which finding critical numbers is just one step of these long problems. But if you can't find the critical numbers, you can't do these long problems. So we're going to spend some time just finding critical numbers, practicing that very vital step of finding critical numbers. Mostly what I'm practicing here for you is algebra. The derivatives we should be pretty good at by now, but some of us need a little help with our algebra. So how to find critical numbers. 1, find the derivative. And that's kind of the end of the calculus right there. Find the derivative. 2, set the derivative equal to 0 and solve. 3, if the derivative is a fraction, to find where the derivative does not exist, set the denominator of the derivative equal to 0 and solve. Because there are two types of critical numbers. A number c in the domain of f of x is a critical number of f of x if f prime of c equals 0 or f prime of c does not exist. Step 2 gives us the first type, where the derivative is 0. Step 3 gives us the second type, where the derivative doesn't exist. So let's find critical numbers. So step 1, find that derivative. Going to remember that in a cube root is the same thing as exponent of 1/3. Then I'm going to use the chain rule. And I'm going to multiply by that exponent, decrease the exponent by 1, chain rule, times the derivative of the exponent, and then simplify this. So that's going to be 2x over 3 times x squared minus 2/3, x squared minus 1 to the 2/3. If you want to take it back to radical notation, you can. Fractional notation will be sufficient. Went to the fractional notation because of look what step 3 says. If the derivative is a fraction. So there's the first step. Check your derivatives twice, 3 times. If your derivative is wrong, these long problems that we're building to, if your derivative is wrong, everything else will be wrong after that. So check your derivatives twice. 2, I set f prime equal to 0. So I get 2x over 3 times x squared minus 1 to the 2/3 equals 0. And here's what we're really practicing. Remember how to solve some basic equations. An equation with a fraction. Your easiest thing to do is clear the fraction. Multiply all terms on both sides. By the common denominator. Equations with fractions, clear the fractions. So in this case, I'm going to multiply both sides by that denominator. On the left, They cancel. So I get 2x, and on the right, 0 times anything except infinity. And we'll talk more about 0 times infinity actually later on. But anything times 0 times anything other than infinity is 0. And so we get x equals 0. So there's one critical number. But my derivative turned out to be a fraction. And so then to find where f prime does not exist, I set the denominator of f prime equal to 0. Because if you divide by 0, bad things happen. Now, I'm going to beat this guy to death in getting this answer. I would have no problem with people telling me that the answer to this equation is plus or minus 1. But beating this to death, divide both sides by 3. So I have x squared minus 1 to the 2/3 equals 0. Raise both sides to the reciprocal power. And so I'm going to get x squared minus 1 equals 0. 0 to any exponent other than infinity is 0. And then x squared equals 1. And very importantly, when I take the square root of both sides, plus or minus 1. And so there are my critical numbers. 3 numbers, -1, 0, and 1. Things we want to remember here. There are 2 types of critical numbers. If your derivative is a fraction, be sure you look for that does not exist case. And then the other thing that's incredibly important here, if you ever take the square root of both sides, you got to include that plus or minus there. Forgetting the plus or minus can take a problem that I set up to work out pretty nicely to a problem that doesn't work out at all. Can't make those little algebraic errors. So there are our first set of critical numbers. Okay, next set of critical numbers. Find the critical numbers of the following. Okay, step 1, find the derivative. Product rule. And recall that the derivative of e to the mx is m e to the mx. Repeats derivative of the exponent. So f prime of x, product rule. And I will write it out because I know it's been a while since we've seen it. Plane first, derivative of the second, plus plane second, derivative of the first. Then doing that, that's x minus 5 quantity cubed, -2 e to the 2x, and if you don't remember that part, you can remember repeats derivative of the exponent, repeats derivative of the exponent, and then e to the -2x. And doing that derivative on the end with a chain rule, multiply by the exponent, decrease the exponent by 1, derivative of the inside times 1. So that was a chain rule on x minus 5 quantity cubed. Now let's simplify this a little bit. So we're going to have -2 e to the -2x, x minus 5 quantity cubed, plus 3 e to the -2x, x minus 5 quantity squared. First step is simplification. Let's factor that. They both have both terms have a factor of e to the -2x. They both have a factor of x minus 5 quantity squared. So I can take out an e to the -2x, x minus 5 quantity squared, which will then leave behind a -2, I took out the e to the negative 2x. I had 3 of x minus 5 cubed. I took out 2 of them. So I have a single x minus 5 squared left behind. Didn't do anything with that 3, so that 3 is still there. Took out the e to the negative 2x. Took out x minus 5 quantity squared, so all that's left is 3. Distribute here. So that's going to be negative 2x plus 10. And so nicely simplified, we got e to the negative 2x, x minus 5 quantity squared, negative 2x plus 13. And there's my simplified derivative. And if you prefer, and I do prefer, so I'll take it one more step, because I do sort of like to see things as fractions when I can, so that I don't forget about that second type of critical numbers, that where I'm undefined. Okay, set this thing equal to 0 and solve. And so that'd give me x minus 5 quantity squared, negative 2x plus 13 over e to the 2x equals 0. Clear the fractions. Equations with fractions, just like we said in the last one, clear the fractions. You're going to hear me say that over and over again. And now there's an easy way and a hard way to do this. The hard way would be multiply all that out. Please do not do that. This is factored equal to 0, so it's legal to split up. Only legal to split up when it's equal to 0, because of the zero factor theorem that says if two numbers multiply to be 0, or more than two numbers multiply to be 0, one of them must be equal to 0. But incredibly important, it is equal to 0. It's factored and equal to 0. So I can split this up. And very technically, I have x minus 5 equals 0, x minus 5 equals 0, negative 2x plus 13 equals 0. So I get x equal 5 and x equal 13 halves. And there are my first critical numbers. Now this guy was a fraction. So we said that f prime was x minus 5 quantity squared, negative 2x plus 13 over e to the 2x. So where f prime does not exist would be e to the 2x equals 0. Exponential equation. I take the natural log of both sides. And so that'd give me natural log of e to the 2x equals natural log of 0. Then we did review this. Natural logs and e's were inverses, so that gives me 2x equals 0. And then we did review this. This is undefined. And so there is no solution here. And when you saw the problem, the minute you saw e to the 2x is 0, some of you are going to know, well, that's never 0. So then you can ignore it. But here, the does not exist case didn't happen. We looked at where the denominator might be 0. We didn't get a solution, so it didn't happen. But if your derivative is a fraction, always think about that does not exist case. It might not happen, but you need to think about it. So the critical numbers I got were 5 and 13 halves. And that concludes this video.